The James Webb Telescope has uncovered the clearest image of Proxima B in history, revealing dazzling insights into a potentially viable exoplanet. It guides us as we embark on a journey through space to uncover the mysteries of Proxima B and determine whether it could be the next Earth. Let's take off into the vast expanse of space, where a mysterious planet exists in the habitable zone of its star, Proxima Centauri. This planet isn't just any ordinary rock. It's fascinating. Proxima B is located a mere 4.2 light-years from us and is shrouded in secrets and wonders. Could it be another Earth, with oceans and life thriving on its surface? But wait, there's more. Proxima Centauri B isn't alone in its system. Orbiting the red dwarf star, it has a companion, Proxima Centauri C. Who knows what other secrets this star system holds? Perhaps there's another companion we haven't yet discovered. The mystery doesn't stop there. Proxima Centauri emits roughly the same amount of energy to its planet as Earth receives from the Sun. Could this mean there's water on its surface? And maybe even life? As we explore beyond our solar system, we encounter a vast universe of exoplanets, planets that orbit stars other than our Sun. With 200 billion stars in the universe, the opportunities for exoplanets are endless. Some of these planets even wander freely, untethered to any star, like cosmic nomads drifting through space. Among them, Proxima Centauri B stands out as a particularly striking and captivating planet. Its year lasts only 112 Earth days, and it orbits much closer to its star than Earth does to the Sun. One side of the planet is constantly bathed in sunlight, while the other remains in eternal darkness. Now let's examine Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system, which includes Rigil Kentaurus, also known as Alpha Centauri A, and Alpha Centauri B together. These stars form the closest star system to our solar system. Rigil Kentaurus and Alpha Centauri B create a binary system, appearing as a single bright star in the Centaurus constellation, the third brightest star in our night sky. Proxima Centauri, also called Alpha Centauri C, is a red dwarf or M-type star located 21 light-years from the other two stars, over 10 times the distance between Earth and the Sun. In fact, Proxima means nearest in Latin, and the star was discovered in 1915 by Scottish astronomer Robert Thorburn Aideninus. Despite being our closest stellar neighbor, it is not visible to the naked eye, with an apparent magnitude of 11.13, much fainter than the human eye's limit of 6.5. But don't be fooled. Proxima Centauri is still a fascinating star to study. Red dwarfs like Proxima Centauri are among the most efficient in energy production. Though they don't emit much energy, their internal convection processes allow them to shine for trillions of years. In fact, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of planets around red dwarfs like Proxima Centauri is still debated. For one, it is a flare star, meaning it experiences frequent and intense eruptions. As a low-mass star, its habitable zone is much closer than the Sun's, estimated to be between 0.023 and 0.054 Australian dollars. However, it may not be as habitable as it seems. Proxima B is bombarded by extreme ultraviolet radiation from its star, far stronger than what Earth receives from the Sun. This radiation is so intense that even the lightest elements, like hydrogen, are stripped away, along with nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may lack a stable atmosphere, which is crucial for regulating temperature and maintaining liquid water. Without an atmosphere, life would be vulnerable to harsh space conditions, making survival nearly impossible. So, while Proxima B may appear Earth-like on the surface, it is far from being able to sustain life. Scientists remain cautious, as many factors could render it inhospitable. The quest to uncover the truth about Proxima B continues, and some still hold hope. One of the most promising tools for this search is the James Webb Space Telescope. After years of anticipation, the telescope was finally launched in 2021, aiming to help determine if life exists on Proxima B. However, as with all scientific discoveries, things are never as simple as they seem. Adjustments were necessary to ensure the James Webb Telescope provides accurate images. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima B absorbs light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light, allowing it to capture images of the planet's surface and search for patterns that could indicate the presence of water or an atmosphere. But what if the planet has an atmosphere that isn't suitable for life? The presence of an atmosphere doesn't guarantee habitability, warns Ed Turner, an astrophysicist at Princeton University. Proxima B could be more like Venus, with a thick, dense atmosphere and extreme temperatures that make life impossible. The journey to unravel the mysteries of Proxima B is not without its challenges. While the James Webb Telescope offers hope, other factors must be considered. With rising costs, space scientists feel pressure to find efficient ways to observe planets like Proxima B. Much is at stake, but the rewards are even greater. The opportunity to explore the unknown and uncover the secrets of a distant planet that may hold the potential for life. If Proxima B were habitable, could we one day visit? Being the closest exoplanet to us makes it an intriguing prospect. Even more exciting, it is similar in size to Earth, and its location in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it an ideal target for our search for life beyond Earth. Being so close, it is a prime candidate for interstellar missions. Imagine exploring this Earth-like exoplanet. Although we can't travel there yet, it is certainly on the radar for future missions. As technology advances, exploring Proxima B becomes one of the most exciting frontiers in space exploration. However, it's no easy task. It would take a spacecraft like Voyager 2 approximately 75,000 years to reach the Proxima Centauri system. While current technology limits our ability to reach Proxima B within a human lifetime, scientists and engineers are already considering revolutionary approaches to interstellar travel. Concepts like Breakthrough Starshot, a project aiming to send ultralight spacecraft powered by laser propulsion, could reduce travel time to just 20 to 30 years instead of thousands. These small, high-speed probes, called star chips, would be accelerated by powerful Earth-based lasers to a fraction of the speed of light. If successful, they could reach the Proxima Centauri system within a few decades, sending back data about Proxima B's atmosphere, surface conditions, and potential signs of life. However, numerous challenges remain. The journey would require overcoming intense radiation, navigating interstellar dust, and ensuring reliable communication across vast distances. Even if a probe successfully reached Proxima B, transmitting meaningful data back to Earth over 4.2 light-years would be another major hurdle. The big question: could humans ever live on Proxima B? Even if Proxima B had liquid water and a stable atmosphere, life there would be vastly different from Earth. The planet's tidal locking, where one side permanently faces its star while the other remains in eternal darkness, could create extreme weather patterns. If an atmosphere exists, powerful winds might circulate between the two hemispheres, creating a habitable twilight zone in between. But there's another concern: Proxima Centauri's violent flares. Unlike our Sun, this red dwarf frequently emits intense bursts of radiation, which could strip away a planet's atmosphere over time. For life to exist, Proxima B would need a strong magnetic field, similar to Earth's, to shield it from harmful radiation. If it lacks this protection, its surface could be barren and uninhabitable. Some scientists suggest that life on Proxima B, if it exists, might be radically different from anything on Earth. It could be underground, in deep oceans, or protected beneath ice or thick atmospheric layers. These possibilities drive researchers to continue studying exoplanets, searching for biosignatures that indicate alien life. The future of exoplanet exploration. The study of Proxima B is just the beginning. With next-generation telescopes like the James Webb Space Telescope, the upcoming Nancy Grace Roman Space Telescope, and ground-based observatories like the Extremely Large Telescope, ELT, scientists will gain unprecedented insights into distant worlds. These telescopes will help us analyze exoplanet atmospheres, detect possible water vapor, and even search for chemical markers of life, such as oxygen, methane, and carbon dioxide. While the discovery of an Earth-like world around our nearest star is thrilling, the search for a truly habitable exoplanet continues. Could there be an even better candidate within a few dozen light years? Could Proxima B surprise us with hidden life beneath its surface? Only time and new technology will tell. Until then, Proxima B remains one of the most exciting and mysterious exoplanets in our cosmic neighborhood. An arrangement has been proposed: sun-powered sails. These ultra-thin sails could be utilized to drive a shuttle to the Alpha Centauri system and Proxima alongside it. This innovation utilizes solar pressure to keep the shuttle on course, eliminating the issue of running out of fuel. And here's something significantly cooler. This state-of-the-art technology could provide insights into the possibility of life on different planets like Proxima. However, like anything ambitious, there are challenges. For example, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima B could be similar to Venus, with a thick, hot atmosphere that is inhospitable. Besides, get this, the James Webb Telescope can detect such emissions if they reach a brightness of just 5% of the daytime side. Now, 5% may not seem like much, but when dealing with a star that is generally dimmer than our own sun, it's quite significant. If Proxima B has advanced civilizations, they might use giant orbital mirrors to reflect sunlight from the daytime side to the nighttime side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being massive gas giants while others resemble our own Earth. But what do we know about them? One type of exoplanet that has grabbed the attention of space researchers is the gas giant. These planets are similar in composition to Jupiter and Saturn, but are much larger. Some of these behemoths have been named super Jupiters, surpassing even the largest planet in our solar system. But that's not all. There are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in a blistering environment with temperatures that could melt metal. Imagine seeing such a planet up close, with its raging storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are hot Neptunes and mini Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in thick atmospheres, making them difficult to study from afar. And let's not forget the Earth-like exoplanets, which resemble our own planet. These planets vary in size, ranging from smaller than Earth to twice its size. There are even super-Earths, which have masses more than twice that of our planet, but are lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth, with an estimated mass of 7 Earth masses. It orbits within the habitable zone of its host star, and researchers are currently investigating whether it could support life. Proxima Centauri b is particularly noteworthy because it is the closest potentially habitable planet to our solar system. As we continue to explore these intriguing worlds, the James Webb Telescope promises to provide even more insight into their potential for life and habitability. The allure of Proxima Centauri lies not only in its proximity, but also in the tantalizing possibility that it may harbor conditions favorable to life. As we probe deeper into the exoplanet's characteristics, the question on every scientist's mind is whether Proxima holds the keys to understanding life beyond Earth. While it may be a rocky world, its orbital position within the habitable zone and its potential for liquid water make it an exciting target for future exploration. However, there's a catch. Proxima Centauri b's closeness to its star means it could be exposed to dangerous radiation, especially since red dwarf stars like Proxima Centauri are known for their violent flares. These flares, which emit intense bursts of radiation, could strip away a planet's atmosphere over time, making it difficult for life to take root. Proxima B may also experience tidal locking, a condition where one side of the planet is permanently facing the star while the other remains in darkness. This could lead to extreme temperature differences between the two sides, complicating the conditions needed to sustain life. Yet, there are still many uncertainties. We don't fully understand how the planet's atmosphere interacts with its environment. For instance, could Proxima B have a protective magnetic field that shields it from the star's radiation? This would be crucial for supporting life on the planet. Moreover, the possibility that life, if it exists on Proxima B, could have adapted to the harsh environment cannot be ruled out. Life on Earth, after all, has managed to thrive in even the most extreme conditions, from the depths of the ocean to the frozen tundra. Could Proxima B host a different form of life, one that survives under challenges we can't yet imagine? In addition to these considerations, Proxima B's proximity to Earth makes it a prime candidate for interstellar travel, especially with future advancements in space technology. While our current spacecraft, like Voyager 2, would take thousands of years to reach the system, more ambitious projects are being proposed. For example, solar sail technology offers a potential solution. Using the pressure exerted by sunlight, solar sails could propel spacecraft at a significant fraction of the speed of light. This method could bring us closer to realizing the dream of sending probes to explore distant exoplanets like Proxima B. The potential to one day send humans to Proxima B is an even more enticing prospect. While this remains far in the future, it fuels our imagination and underscores the importance of continued exploration and research. For now, the James Webb Space Telescope will serve as our eyes into this distant world. It will monitor Proxima B's atmosphere, study its surface, and gather crucial data to help us determine whether it can support life. Through its infrared capabilities, Webb can provide valuable insights into the planet's atmospheric composition, bringing us closer to understanding whether Proxima B might one day be a second home for humanity. As we move forward, it's clear that exploring exoplanets like Proxima B offers more than just the chance to find alien life. It also represents our desire to understand the universe and our place within it. Every discovery, every piece of the puzzle, brings us one step closer to answering fundamental questions about life, the cosmos, and what the future holds for humanity. Whether Proxima B turns out to be habitable or not, the journey of exploration will continue to inspire and shape our future. The next frontier, humanity's journey beyond. As our understanding of exoplanets deepens, the dream of interstellar exploration becomes more tangible. While traveling to Proxima Centauri B remains beyond our current capabilities, the rapid advancements in space technology suggest that one day, a mission to this distant world might be feasible. One of the most promising technologies under development is the concept of light sails, which leverage laser propulsion to accelerate spacecraft to unprecedented speeds. The breakthrough Starshot initiative, for example, envisions sending tiny probes equipped with light sails, propelled by powerful ground-based lasers. These probes could reach 20% the speed of light, potentially arriving at Proxima Centauri B in just 20 years, rather than thousands. If successful, they could send back images and data, providing our first close-up look at an exoplanet beyond our solar system. In parallel, advancements in fusion propulsion and antimatter-based engines are being explored as potential solutions for crewed interstellar missions. Though still theoretical, these technologies could one day allow human explorers to traverse the vast distances between stars. The search for life. What lies beneath? As we peer deeper into the universe, the search for extraterrestrial life remains a central focus of modern astronomy. While planets like Proxima Centauri B sit within the habitable zone, habitability is a complex puzzle that goes beyond just temperature and water availability. Scientists are now considering the role of subsurface oceans, which could provide refuge for life even on planets that appear inhospitable on the surface. Jupiter's moon Europa and Saturn's Enceladus are prime examples within our solar system. Icy worlds with hidden oceans beneath their frozen crusts, warmed by geothermal activity. Could similar conditions exist on exoplanets? If so, life may not be limited to surface dwellers, but could thrive in the depths of alien oceans, shielded from radiation and extreme temperatures. Another key consideration is biosignatures, chemical traces that indicate biological activity. Instruments aboard the James Webb Space Telescope, JWST, are now capable of detecting atmospheric gases like oxygen, methane, and carbon dioxide in exoplanet atmospheres. If we were to find an unusual combination of these gases, such as methane and oxygen coexisting, it could hint at biological processes at work. Even more exciting is the possibility of detecting technosignatures, evidence of advanced civilizations. This includes detecting artificial light, unusual radio signals, or even signs of megastructures like Dyson spheres, which theoretical civilizations might construct to harness the energy of their stars. Humanity's cosmic destiny. The quest to explore exoplanets is more than just a scientific endeavor. It speaks to something deeply embedded in our nature, the desire to explore, to push boundaries, and to seek answers to the biggest questions of existence. Are we alone in the universe? If life exists elsewhere, what does it look like? Could there be civilizations more advanced than our own? And perhaps the most profound question, what is humanity's place in the grand cosmic story? As technology progresses, we may one day send not just robotic probes but human pioneers to distant worlds. The first explorers of Proxima Centauri B might set foot on an alien surface, gazing at a dim red sun in the sky, knowing they are the first humans to step beyond our solar system. For now, we rely on telescopes and theoretical models, but the future holds limitless possibilities. Each discovery brings us closer to a reality where the stars are no longer out of reach, but destinations awaiting our arrival. The journey continues, and with each new breakthrough, we take another step toward a future where humanity is no longer confined to one world, but truly interstellar.